Hello everyone, I'm Teacher Michelle and welcome to another episode of Unang Math. In this episode, I will discuss what like terms are. In our previous episode, we are done with multiplication and division of linear expressions. Multiplication and division of linear expressions are easy because we will just multiply or divide the numbers, then write the variable after the number. Addition and subtraction of linear expressions are a bit different. Before adding or subtracting linear expressions, first, you have to understand what like terms are. Okay, when we say like terms, these are terms with the same variable and the same degree. Let's give an example for you to understand like terms. We have here 8 terms. 5x, negative a, 7, 3x squared, negative 1 over 4x squared, 0.8x, negative 2 over 5, and 9a. Now, let's combine or let's check those terms that are considered like terms. 5x and 0.8x are like terms. Remember, when we say like terms, these terms have the same variable and degree. Same variable x and same degree, so these two terms are like terms. Okay, another, negative a and 9a. Variable a and same degree, so these are also considered like terms. 7 and negative 2 over 5. If you're going to ask, they don't have variables. These are just numbers. Okay, 7 and negative 2 over 5 are constant terms, and constant terms are considered like terms. We also have 3x squared and negative 1 over 4x squared. Variable x and same degree 2, so these terms are also considered like terms. So in combining like terms, we will not focus on the coefficient, but rather to the variable and the degree. So if they have the same variable and degree, then those are considered like terms. So what are the conditions for like terms? Or when do we say that those terms are like terms? First, the terms must have the same variable and degree, regardless of the coefficient. So we will not care about the coefficient, but we will check the variable and degree. They must have the same variable and degree to be called like terms. Okay, second, all constant terms are like terms. In an expression, okay, sometimes we see constant term or constant terms. Constant terms are considered like terms. Third, if either the variable or the degree is different, they are not like terms. Example, 3a and 4x. A and x are different variables. So these two terms are not considered like terms. Let's give more examples. Okay, I have here this expression 5x plus 4 minus 2x minus 1. 5x is one term, 4 is another term, negative 2x another term, negative 1 is another term. Okay, let's combine or let's identify those like terms in this expression. Okay, we have 5x and negative 2x. These two terms are considered like terms. Same variable and same degree. Okay, what else? 4 and negative 1. These are constant terms in this expression, and these are considered like terms. Okay, next example. 3x minus 2y plus x squared minus 5xy plus 4 minus 6x plus 3y minus 7. 3x is a term, negative 2y also. x squared, negative 5xy, plus 4 or 4, negative 6x, 3y, and negative 7. In this expression, we have 8 terms. Okay, let's combine or identify those like terms in this expression. Okay, we have 3x and negative 6x. So these two terms are considered like terms, same variable and degree. Okay, we also have negative 2y and 3y. Same variable and same degree. These terms are considered like terms. Okay, how about for x squared? If we will check for this expression, we cannot find any more term or other term that has the same variable and degree. So x squared is not considered like term because it doesn't have a partner with the same variable and degree. Okay, another, negative 5xy. We cannot find also the same variable xy and the same degree. So negative 5xy is not considered like term. Okay, next, 4 and negative 7. These are constant terms in this expression. And these terms are also considered like terms. Okay, let's move on. This time, let's add like terms. In adding like terms, we will use the distributive property to add the coefficient of like terms. Then we will write the sum in front of the variable. Okay, let's give an example. 3a plus 2a. So using the distributive property, we will add the coefficient of like terms. Okay, 3a is 3 times a. So we restore the multiplication symbol. So 3 times a plus 2 times a. 2 times a is 2a. Okay, let's use the distributive property to add the coefficient of like terms. So 3 plus 2 inside the parenthesis, and this is multiplied by a. 3 plus 2 is 5. So 5 times a, this is equal to 5a. Okay, how about negative 3a plus 2a? Restore the multiplication symbol. So this is negative 3 times a. Okay, plus 2 times a. Okay, negative 3a using the distributive property, negative 3 plus 2 inside the parenthesis times a. Negative 3 plus 2 is negative 1. So negative 1 times a is negative 1a or negative a. Okay, now let's take a look at this third example. 3a plus 2b. A and b, or these variables, are not the same. So these two terms are not considered like terms. So 3a plus 2b is already the simplified expression. We can no longer simplify this expression because these two terms are not like terms. Okay, let's move on. This time, subtraction of like terms. It's the same rule. The operation is just different. So we will still use the distributive property to subtract the coefficient of like terms. Then we will write the sum in front of the variable. Okay, example, 3a minus 2a. So using the distributive property, first, let's restore the omitted multiplication sign. So 3a is 3 times a minus 2a is 2 times a. Okay, using the distributive property, inside the parenthesis, 3 minus 2, and this is times a. 3 minus 2 is 1. So 1 times a is equal to 1a or a. How about negative 3a minus 2a? So this is negative 3 times a minus 2 times a. Okay, using the distributive property, let's put negative 3 minus 2 inside the parenthesis, and this is multiplied by a. Negative 3 minus 2, this is negative 5. So negative 5 times a is equal to negative 5a. Okay, this time, we are now ready to answer this simple activity. Okay, if 6x plus 5 plus 3x minus 2 is equal to ax plus b, what is the value of a minus b? Take note that a and b, these are constant. Okay, let's get this expression 6x plus 5 plus 3x minus 2. Okay, we will combine those like terms in this expression. Okay, 6x, we have 6x and 3x. These are like terms, same variable and degree. So 6x plus 3x, this is equal to 9x. Okay, plus 5. Okay, we have here 5 and negative 2. These are also like terms. And these are the constant terms in this expression. So 5 minus 2 is 3. So we have 9x plus 3. This is the simplified form of this expression. And we did that using, by combining like terms. Okay, this is equal to ax plus b. So it means, okay, a is equal to 9, b is equal to 3. So 9 minus 3, a minus b. So 9 minus 3, that means the answer is 6. Okay, for this next activity or problem, calculate the following, and this is for you to answer. Okay, 5x plus 2y minus 5 minus 2x plus 7 plus y. So to answer this one, you have to combine those like terms in this expression. So if you are going to see 5x and negative 2x, these are like terms. 2y and y also like terms. Negative 5 and 7 are also like terms. So calculate and you may write your answer in the comment section.